Okay, we are going to start question number 9. The constant a is such that integration of 6x ln x dx is equals to 4. Show that a is equal to exponential of 1 over 6 times 5 over a square plus 3, where exponential of x denotes e to the power of x. Okay, we have the integrate from 1 to a. 6x ln x dx equals to 4, and we need to find the value of a. In this integration, we have the two functions which are multiplied. So we will use integration by parts, which says that integration of u and v with respect to dx is equals to u integration of v with respect to x minus integration derivative of u with respect to x integration of v with respect to dx and whole integration. So this is the product rule, or you can say that integration by parts. So here in this case, u is equals to ln x and v is equals to x. Now apply this formula. So here 6 times integration from 1 to a x ln x dx, and this one is equals to the u, which is ln x. Integration of v means integration of x with respect to x and multiply by 6 minus integration derivative of u means derivative of ln x with respect to x, and then integration of v with and whole integration, and we have the limit from 1 to a. We will apply later, and this one is equals to 4. Further solving, we will have 6 times ln x time integration of x is x square over 2 minus derivative of ln x is 1 over x, and the integration of x is x square over 2, and this one is whole integration, where the limit is from 1 to a. This one is equals to 4. Further solving, we will have 6 x square over 2 ln x minus x will be cancelled out, and we will have integration of x over 2 with respect to x, and limit from 1 to a equals to 4. 6 x square over 2 ln x minus 1 over 2 is constant multiple, so x integration of x is x square over 2, and we have the limit from 1 to a, and this one is equals to 4. Now apply the upper limit. So 6 times upper limit is a square over 2 ln a minus 1 over 4 a square minus, now apply lower limit, 1 square over 2 ln 1 minus 1 over 4 1 square, and this one is equals to 4. Further solving, we will have 6 times a square over 2 ln a minus 1 over 4 a square, and we know that ln 1 is equals to 0, so this whole term will be 0, and we will have plus 1 over 4, and this one is equals to 4. Now multiply by 6, we will have a square ln a over 2 6 times minus 6 a square over 4 minus 6 over 4 equals to 4. Sorry, this one is plus, and further solving, we will have this one is 3, so 3 a square ln a, and this one will be equals to 2 and 3, so we will have minus 3 over 2 a square, and this one is equals to 3 over 2 plus 3 over 2 equals to 4. 3 a square ln a minus 3 over 2 a square equals to 4 minus 3 over 2, and this one is equals to 8 minus 3 over 2, which is equals to 5 over 2. Okay, taking a square common, we will have a square 3 ln a minus 3 over 2, and this one is equals to 5 over 2, and we take LCM, a square 2 as a LCM, and this one will be equals to the 6 ln a minus 3, which is equals to 5 over 2. 2 will be cancelled out, and we will have 6 ln a minus 3 equals to 5 over a square. Switching negative 3 on the right side, we will have 6 ln a is equals to 5 over a square plus 3. And we need to find the value of a. So we will have ln a is equals to 5 plus 3, 5 over a square plus 3 times 1 over 6. Exponential both sides. So we will have a is equals to exponential of 1 over 6 times 5 over a square plus 3. And this was the required value of a. And we have proved that a is equals to the exponential of 1 over 6 times a 5 over a square plus 3. Okay, part B, verify by calculation that a lies between 2 and 2.1. Okay, we will use this equation to prove part B. So we have 6 ln a minus 3 equals to 5 over a square. Okay, multiply a square on the left side, we will have a square 6 ln a minus 3a square equals to 5. Now let's suppose that left hand side is the function of a, which is 6a square ln a minus 3a square. And this f of a is equals to 5, and we need to verify that a lies between 2 and 2.1. So first we plug f of 2, and this one is equal to 6 times 2 square ln 2 minus 3 times 2 square. Solving this one, we will have 6 times 4, which is 24, ln 2 minus 2 times 4 is 12. Using calculator, 24 times ln 2 is equal to 16.635 minus 12. So we have f of 2, which is equals to 4.6355, which is less than the output value 5. Now let's find f of 2.1. f of 2.1, which is equals to 6 times 2.1 square ln 2.1 minus 3 times 2.1 square. So this one is equals to 26.46 ln 2.1 minus 13.23. Further solving, we will have 26.46 times ln 2.1 is 19.6316 minus 13.23. So this one is equals to the f of 2.1 is equals to 6.40, which is greater than 5. So we can say that the a will lie between 2 and 2.1 such that it will achieve the value of 5. Okay, let's move to the part C. Use an iterative formula based on the equation in part A to determine a correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So we have the a, which is equals to exponential of 1 over 6 times 5 over a square plus 3. Apply iterative method. So we will have a n plus 1 equals to exponential of 1 over 6 times 5 over a n square plus 3 over. Now let's suppose that a naught is equals to 2. When we plug a naught equal to 0, we will have a1, which is equals to exponential of 1 over 6 times 5 over a square plus 3, and this one is equals to 2.030604. Now let's suppose a2, which is equals to exponential of 1 over 6 times 5 over 2.0306 square plus 3, and this one is equals to 2.0179. Now finding a3, which says that exponential of 1 over 6 times 5 over 2.0179 square plus 3, and this one is equals to the 2.0231. Now plugging 2.0231, we will have a4, which is equals to exponential of 1 over 6 times 5 over 2.0231 square plus 3, and this one is equals to the, so we will have 2.0210. Now we can see that These two value have common two decimal places like 2.02, 2.02. So two decimal places 02 and 02 is same. So we can say that A is equals to 2.02. This was the required result.